That's exactly what happened on June 27, 2025, when a lone Ukrainian MiG-29 set out to destroy one of Russia's most critical drone factories deep behind enemy lines. But what unfolded next wasn't just a daring mission. It was a masterclass in outsmarting the most advanced air defenses on Earth. Stick around, because in the next few minutes, you'll hear how this pilot dodged S-400 missiles, tricked electronic warfare systems, and turned a decades-old jet into a precision strike machine. If you love hearing true high-stakes combat stories like this, hit subscribe and turn on notifications, because you won't want to miss what's coming next. At 14:45 local time on June 27, 2025, a Ukrainian MiG-29 from the 40th Tactical Aviation Brigade banked hard left as its weapons interface erupted in voltage warnings, while the flight to the Russian drone factory had been routine so far. This would all change in a matter of seconds. Then, in an instant, his radar warning receiver screamed to life. An S-300 acquisition radar had just locked onto him from 95 kilometers away. The calm of the mission evaporated. Everything was about to change. Reacting instantly, the pilot shoved the MiG down to just 500 feet, skimming the terrain to stay hidden from enemy eyes. In the cockpit, the GBU-39 smart bombs were going through their startup ritual, acquiring GPS locks, calibrating inertial systems, and syncing with the jet's improvised weapons interface. Normally, it's a quick 30-second process, but now, 2 full minutes had ticked by. Finally, at 14:48, all 4 bombs flashed green. They were ready, though the tension in that cockpit was anything but. On his tablet, the target coordinates glowed locked on a drone factory buried 350 kilometers inside occupied territory. This wasn't just any plant. It churned out around 40 Shade 136 kamikaze drones every single week. Intel warned the site was guarded by a Kushuka-4 electronic warfare vehicle, blasting 500 watts of GPS jamming power into the air. The pilot checked his fuel readout just enough for 2,100 kilometers in total. After releasing the bombs, he'd have a razor-thin window. 18 minutes to make it back through hostile skies before hitting bingo fuel. The tension ratcheted up. The S-300's radar sweep grew sharper, and now an SA-15 system was joining the hunt from the southeast. In just 6 minutes, he'd need to climb to 15,000 feet to get the proper release angle for the bombs, an altitude that would put him in full view of every air defense operator in the region. The GBU-39s could glide over 100 kilometers from that height, but first, they'd have to survive a climb straight through a storm of electromagnetic interference, powerful enough to fry most commercial electronics. Somewhere deep inside that tangle of battlefield wiring, Ukrainian ingenuity was wrestling with Soviet-era electrical standards, 2 worlds of engineering, fighting for control of 4 American-made precision weapons. He shoved the throttles forward, and the twin RD-33 engines roared back over 18,000 pounds of thrust each, pushing the MiG into contested airspace at 14:51. In a heartbeat, every threat warning lit up at once. S-400 radars from Melitopol, mobile SA-15s moving to cut him off, and creeping into his headset the first ghostly traces of Kushuka jamming, bleeding across GPS frequencies. In 19 minutes, he'd learn whether 4 precision bombs bolted to Soviet wings with salvaged tank parts could survive the deadliest air defense network outside Moscow. At 15:15, he rolled right, sliding into an 8-kilometer gap between 2 overlapping S-300 coverage zones. Ukrainian intelligence had mapped this exact corridor, threading the space between 2 ridgelines for the next 7 minutes. Flying low kept him hidden from radar, but it was a knife-edge path. Drift just 2 kilometers left, and the Western S-300 would paint him. 3 kilometers right, and an SA-15 patrol would have him dead to rights. The gap wasn't luck, it was physics. The S-400 near Melitopol couldn't see below 800 feet at that range, and the S-300s were tuned for high-altitude threats, leaving blind spots at the deck. Then, a new spike on the radar warning receiver, a mobile SA-15, had stopped in its tracks. Its crew must have sensed something was off. Moments later, their 9S-36 search radar lit up, sweeping for exactly what he was doing, slipping through their defensive seam. He pushed even lower, now just 400 feet above a bone-dry riverbed. The MiG's fuselage skimmed so close to power lines once that hadn't shown up in mission planning images that there was no room for error. At 1522, he yanked the stick back, pulling a hard 4G climb toward 15,000 feet. Instantly, the cockpit lit up like a Christmas tree. Multiple fire control radars locked on, and the S-400's powerful gravestone radar burned through Ukrainian jamming with sheer brute force, 350 watts of raw energy slamming into the MiG, heating its nose cone as if it were under a blowtorch. The clock was brutal. He had exactly 90 seconds before he'd drift into the S-400's kill zone, where its 48 N-6E missiles could erase him in less than 25 seconds. That narrow sliver of time wasn't by chance, it was choreographed. 45 minutes earlier, Ukrainian Su-24s had launched HARM missiles, knocking out radars near Tokmak. At the same time, electronic warfare teams were feeding the Russians fake radar returns, making it look like a strike package was inbound from the northwest. It worked. Their attention was pulled off course, leaving this lone MiG to slip in from a direction nobody expected. Now, with 12 minutes of fuel left for the trip home, the pilot leveled off at release altitude. Quick question for you. Do you think these kinds of deception tactics, fooling enemy radar with fake strike packages, are the future of air combat? Or just a lucky trick that only works once? Let me know what you think in the comments. I'm curious if you trust this gamble with your own life on the line. The GBU-39s were ready for their final checks. GPS receivers were locked on 5 satellites, position accuracy down to just 3 meters. Target coordinates confirmed. For the last 10 minutes, the Kushuka-4 electronic warfare vehicle near the target had been flooding the airwaves 500 watts of noise-hammering GPS frequencies, trying to blind anything that relied on satellite navigation. But here's the thing. This was exactly the kind of battlefield the GBU-39 had been built for. In just 60 seconds, he'd find out if American engineering could guide 37 kilos of explosive right through one of the most hostile electronic storms on the planet, and stop the drones that had been raining down on Ukrainian cities. At 1528, his thumb pressed the pickle button, and the first GBU-39 dropped free from the starboard pylon. The jet jolted upward as 250 pounds of precision weapon peeled away. Almost instantly, the bomb's GPS receiver was hammered by interference. Within 0.2 of a second, its guidance computer recognized the jamming, ditched GPS, and switched to inertial navigation without missing a beat. The Kushuka crew, 82 kilometers away, had no idea their jamming had just been sidestepped completely. 6 seconds later, the second bomb was away from the port pylon, then the third from the center line, and finally the fourth. Each weapon unfolded its wings exactly 2.7 seconds after release, morphing from a falling lump of steel into a sleek glider with a 20-to-1 lift-to-drag ratio. Their onboard computers instantly plotted unique flight paths, coming in from different angles, so no single-point defense system could stop them all. They had 89 kilometers to fly through hostile skies, arriving 30 seconds apart to tear the target apart in waves. The moment the last bomb was away, he rolled the MiG inverted and yanked it down hard, pulling 5 Gs straight toward the deck. On the radar warning display, SA-15 acquisition radars flipped to tracking mode. They'd finally figured out what he was doing. At 15:29 and 15 seconds, the the nearest battery fired 2 9M9 missiles, but their math was already wrong. By the time they could have reached him, terrain would swallow him from their view, leaving the missiles chasing nothing but ground clutter. Meanwhile, the 4 GBU-39s surged ahead at 180 meters per second, their guidance computers checking navigation 20 times a second, matching accelerometer data to pre-programmed waypoints stored in hardened memory. At 15:31, a brief break in the jamming let GPS signals slip through. The bombs instantly updated their positions and confirmed they were still within 8 meters of their planned flight paths. Even in the most intense electronic warfare environment on Earth, their inertial navigation had kept them razor accurate. At 15:32 and 44 seconds, the first bomb's uncooled infrared seeker locked in. The target's metal roof radiated heat differently from everything around it, a signature the bomb's onboard AI matched to reference images with 94% confidence. It adjusted its fins, diving at a steep 68-degree angle for maximum penetration. 28 seconds later, the second GBU-39 slammed into the electronics workshop right where Iranian-designed autopilot systems were programmed for the Shahed drones. Without that, the factory's finished drones were nothing more than pricey model airplanes. The second strike tore through the reinforced roof, detonating among benches stacked with circuit boards, laptops, and programming rigs. The blast's shockwave wiped out delicate electronics in an instant, while shrapnel shredded whatever survived the first hit. At 15:33 and 41 seconds, the third bomb smashed into the storage warehouse right where 15 to 20 fully built Shahed 136 drones sat waiting for deployment. Each carried 40 kilos of explosives, and when they went up, the secondary blast was massive, vaporizing not just the drones, but the fuel, spare parts, and maintenance gear keeping the operation alive. The fourth bomb hit like a hammer, finishing whatever was left standing. Inside the Kushuka 4 vehicle, operators were just realizing something had gone horribly wrong. Their jamming had performed exactly as intended, flooding GPS channels with noise, yet the weapons had still found their marks. What they didn't know? The GBU-39 had been engineered from the start to shrug off Soviet-era brute force jamming. American designers had baked countermeasures into every circuit after decades of studying Russian electronic warfare. But the mission wasn't over. The MiG pilot still had to make it out alive, and the Russians weren't about to let him go without a fight. At 15:34, he leveled the MiG just 400 feet above the ground, fuel down to 750 kilos. Home was still 180 kilometers away, about 12 minutes of flight, if he kept his speed and altitude perfect. Behind him, the drone factory was now a column of chaos. Secondary explosions from munitions and fuel supplies punched smoke 3,000 feet into the air. On his radar warning receiver, more SA-15 launches lit up the screen. Their 9M9 missiles screamed to Mach 2.8 within seconds. But at this altitude, the terrain ahead would break their lock before they could close the gap. The river valley ahead acted like a natural radar shield. 45 more seconds, and the SA-15s lost him completely, their missiles self-destructing in empty air. 2 Su-35s scrambled to intercept, but by the time they could reach his position, he'd be nearly 75 kilometers closer to home. At 15:38, the MiG crossed the Malakna River, the line where Russian radar coverage gave out. The fighters turned back. Later analysis confirmed it. All 4 GBU-39s had hit within 12 meters of target, even under relentless GPS jamming. Ukrainian ingenuity had turned a 40-year-old jet into a precision strike weapon, and in doing so, had just shifted the balance in the drone war. If you made it this far, what do you think? Was this mission a turning point in modern aerial warfare? Or just one daring pilot's impossible lucky break? Drop your thoughts in the comments. I read every single one. And if you want more real-world combat stories with this kind of intensity, hit subscribe and ring the bell. You'll be first to hear about the next mission where history gets rewritten in the skies.